Hi everyone, I'm Mohammad. I'm from North South University, and today I would like to share work with you that I did during my undergrad thesis and capstone design with my coursemate Tawfique Elahi under the supervision of SHAIKH, SHAWON, AREFIN, SHIMON, and Nova Ahmed. This work is about designing an MFS app in iOS-based feature phones for low-literate marginalized communities. Our research focuses on Bangladesh, where the population is more than 166 million, and there are 170 million mobile phone users, of which 102 million people are actively using mobile internet. Talking about the MFS industry, which has brought financial revolution in the country, there are about 32 million active users who are making it possible to achieve the record of 2.1 billion transactions per day. COVID-19 pandemic has caused a massive surge in this industry. During the lockdown period, salary disbursements, bill payments, business transactions increased significantly, which resulted in 30% increase in the number of transactions and 26% in the number of active accounts. One of the means of accessing MFS is through internet. About 47% of the total mobile subscribers use a 2G network, and there is a 67% of usage gap. In the country, 41% of the mobile subscribers own a smartphone, and the marginalized community are very unlikely to switch to smartphones due to their financial and literacy constraints, which may limit the smartphone adoption rate to 62% only by 2025. Now, the present rate of financial services provided through mobile devices can be divided along the mobile devices functionality, smartphones, and feature phones. Smartphone apps can be generally downloaded from their app store, and it requires an internet connection for using any MFS app. And using both the smartphone and MFS apps requires some level of technical literacy. On the other hand, MFS apps are not available in basic or feature phones because there is no App Store support. Instead, these phones mostly rely on USSD methods, which are facilitated by their mobile carriers. Although USSD methods do not require internet connection, it is often verbose and is a bit complex to understand for marginalized users. Now, the problems at a glance are accessibility barriers, lack of App Store support in feature phones, and the lack of non-smartphone designs. So addressing these issues can play an important role in increasing accessibility and acceptance of MFS among marginalized users, and increasing penetration of MFS among end users, resulting in larger revenue and market share. We designed a four-phase study starting from understanding the challenges of low-literate users, followed by a design sprint, a design probe, and a prototype development phase. The findings from the first study can be grouped into 6 themes. First, the MFS use case. It is used for business transactions. The working class group often use it to send money to their homes. Next, the target group prefers one platform than the other, depending on various factors like transaction charges, adjacency of local agents from their workplaces or home, etc. In addition to calls, texts, and MFS, the users use the device to listen to music or radio. The main accessibility barriers to device use were identified as low literacy and inability to remember the steps. Additionally, we identified that the users had varying level of knowledge regarding the features and benefits of MFS, whereas some of them had trust issues due to frauds and scams done through the MFS channels. All of these issues were then discussed in a design sprint. I'm not covering it entirely for the interest of time. The discussions in the design sprint revealed an immediate requirement to address the low-literate communities initially, as these communities have initiated MFS usage. Hence, we designed a probe to better understand feature phone design space. We designed 2 tasks. The first one is interpreting icons. The objective of this task was to identify how the users perceive the app icons and how can we make icons and symbols accessible and meaningful. The findings suggested that in most cases, the low literate users do not know the implicit meaning of the icons. For example, they perceive the music icon as a spoon, although they knew that it is the go-to app when they need to play music. The participants often compare and provide a meaning of the icons relative to their surroundings and cultural context. For example, they describe the camera icon with a stove and the settings icon with that of a tractor wheel. In the next task, the participants demonstrated their ability to perform various activities within mobile apps live. The basic level consisted of tasks from the apps that are present in almost all phones. Making a call using the phone book, sending a text, for example. The intermediate level included tasks from the apps that do not require internet connectivity, playing the radio, taking a picture, for example. The advanced level included tasks which were comparatively complex, opening a browser, setting up an alarm, for example. The findings from this task can be grouped into two categories: keypad choices and D-pad preferences. It was found that the users preferred to press keys within the reach of their thumb. Additionally, they considered the call key and the end or power key as the decision-making keys, like accept or reject for a task. Moreover, the users were reluctant to use the left and right D-pads. It was seen that the low-literate users prefer phones which has directions printed on D-pads. From the prop session, we found key issues faced by low-literate users when using button phones. Based on our findings, we formulated 3 design guidelines for feature phone app development. Reduce key involvement, use vertical scroll, minimizing D-pad involvement, and focus on meaningful icons that gives users an idea of the activity. These guidelines were followed in developing our prototypes. Our first application prototype was developed in KaiOS. The prototype was initially limited to English due to difficulties integrating local language Bangla support. We conducted a user study to evaluate the prototype's effectiveness without local language support, and the findings reinforced the importance of incorporating local language support into our application for low-literate users. The final prototype that we developed after addressing these issues has 6 screens. The app has been designed to be simple to navigate using the left and right soft keys and the up and down D-pads. The green and red colors on the soft keys have been used to indicate rightward navigation, with the green right soft key moving forward and the red left soft key moving backward. Mixed numeric values have been used in the app, with both Bangla and English numbers used to make it more accessible. The statements screen uses Bangla numbers for displaying user balance, while English is used for typing phone numbers in the input screen. Graphical icons have also been used to aid low-literate users in remembering the icons as a mnemonic for providing inputs. To conclude, the KaiOS marketplace has provided a breakthrough in feature phone solutions by enabling independent applications deployment. And this study explored the possibility of financial applications for low-literate communities and suggests future work to develop applications with more assistive technologies. We believe that this would encourage more researchers to delve deeper into the domain of MFS in feature phones and potentially uncover new insights. Thank you all for your attention.